All right, so we know what these functions look like, hopefully. If I asked you to sketch them, like a y equals e to the x, hopefully you remember from pre-calc what that looks like. I'm going to put it on the same graph here. So if we do a rough sketch, it's an exponential, right? So it really doesn't matter that I have an e there as my base. We know it goes through 0, 1, and then up and to the right. Okay, so that's the e to the x function that we're dealing with. And then, do you remember inverses? All right, your y equals x line. If I want the inverse function of e to the x, then it's going to be the reflection across that y equals x line. So instead of going through 0, 1, it's going to go through 1, 0. And then do we remember what this one is called? That one is the y equals natural log of x. So basically it's this and this are inverse functions. This is your log form. This is your exponential form. This has a base of e. E to the 1 equals x. Okay, that sort of thing. Y equals e to the x. All right, so I just wanted to make sure we know the sketches, because a little bit later we are going to have to do the area between two curves, and you will see some probably e to the x's. I don't know that we'll see the natural log of x, but we'll definitely see that e to the x curve later. All right, now just to review, solving exponential equations. All right, so it means it's going to have an x someplace in the exponent part. So they're going to ask you to solve maybe something like e raised to the x plus 1 is equal to 7. We'll start with a nice little little baby function like that. Okay, now this is a little bit more complicated than what we did before, but if you remember from pre-calc, when you have an x up here in the exponent and you want to solve it, you take the log of both sides. You take the natural log, since we got an e in there, you're going to take the natural log of both sides. So take natural log both sides. So I know we did that in pre-calc, I just don't know how much we did it. So natural log e raised to the x plus 1, and then natural log of 7. All right, and the reason we do that is because now we can start messing with our log rules, right? So if I can do two things. I could just look at this and know immediately that left-hand side is x plus 1, but then the concept of using your log properties, we could jump the frog, and then that'd be in the binomial x plus 1 times natural log of e, but natural log of e is 1. Okay, so either way you want to think about that. So then I've got an x plus a 1 is equal to natural log of 7. All right, now I've just got some basic equation here that I can subtract 1 from both sides. If I don't have a calculator, that's all I got to do. X is going to be the natural log of 7 minus 1. All right, probably might be a good idea to put a set of parentheses around that, because as I wrote that, natural log 7 minus 1, that kind of looked like 7 minus 1 went together. It's not. It's a natural log of 7, and then subtract 1. So this would be an exact answer. And then, I don't know, if for some reason your book says round to the nearest whatever, that means you're grabbing the calculator, you're going to put that in, you'll get a decimal. Okay, so might possibly have to do that. 0.946 if I go out 3 places. All right, so there's an approximate. Okay, so just in case, I don't know which one your book's going to do. It's been a while since I've looked at the answer key. Okay, so do we remember doing that from pre-calc? Taking the log of both sides? Or have we slept too much since then? And we've completely forgot how to do that. All right, now the thing about this, taking the log of both sides, this needs to be isolated, as in I can't have other things being added and subtracted to it. All right, so we probably ought to do one of those. Like if I saw something, and again, not too complicated here, but if I had a 9 minus, say, a 2e to the x equals 7. All right, that e to the x term is not isolated. You got a 9 over here that's floating around, and you got a coefficient in front of it. So you need to get rid of everything and make sure that e to the x term is completely by itself. So I'm going to subtract 9 from both sides, Didn't really need to show work there. Negative 2 e to the x is equal to negative 2. All right, you're still not able to take the log of both sides just quite yet because you've got the negative 2 here in front. So divide by negative 2, get it all the way down so that you are just down to an e to the x is equal to, that's going to be 1. Okay. Natural log of both sides now. Okay. So now it's isolated. Natural log e to the x is equal to natural log of 1. All right. The left-hand side is just going to be x. And then, yeah, 0. So you could leave it like that if you wanted, but we know that the natural log of 1 is 0, so x equals 0. So those are your steps. That one wasn't easy enough that you might have been able to look up there and just real quickly, because 9 minus 2 is 7, so if e to the what's going to give 1 there. I mean, you might have been able to solve that without it, but there's your actual steps for when you need to do it when you can't figure it out. All right, now let's do the other one. How about if I had a log equation? All right, so solving log equations. Okay, again, we did this in pre-calc, so we'll see if we remember. And maybe we'll only have to do one of these. Let's say we had natural log of maybe, say, a 2x minus a 3, and then equals 5. Can't solve it the way it's sitting. Anybody remember what to do? Yeah, it's like sometimes they draw little flowers with all of this. All right, but this is log form. If something's in log form, I can switch it to exponential form. Okay, and then that's the however you think about it. But you start with this base, e raised to the 5 equals that. So some people draw a little through, I never did that, but you're going to go to exponential form. So you take the base on the log, that becomes your base. All right, raised to the 5th power, and then is equal to the 2x minus 3. Now, technically, e to the 5th is a number, right? Because e is a number. All right, but what I would do to get the exact answer, because e goes on forever and ever and ever, just like pi does. So to get the exact answer, add 3, divide by 2. Okay, so add 3 first. E to the 5th plus 3 is equal to 2x. All right, just leave that e to the 5th in there. Divide both sides by 2. E to the 5th plus 3 all over 2. All right, there's your exact answer, because that e to the x would be some yucky decimal. All right, you could then, if it said round to the nearest 10th, you could grab your calculator, e to the 5th plus 3, and then divide by 2. If they want that and they ask you to round out 3 places, they probably do something like 75.707. All right. The only reason I'm putting it in there is because it's in my notes, so that kind of indicates maybe to me that your book asked you to do both answers. All right, just for practice. So just a little bit of review there. Being able to solve an exponential equation, being able to solve a log equation. If you have a log equation, go to exponential form. If you have an exponential equation, take the log of both sides. So actually, think of opposite, right? Exponential, you got to have some logs in there. You got logs, you got to get rid of them. Exponential, so you're going back and forth. All right, so that has absolutely positively no calculus in it whatsoever.